1, 2, 3, 4.
Why is it that that sounded so awesome?
Because of physics.
Everybody's familiar with the old trick where you take a balloon full of helium and you inhale the air so that your voice gets all high and squeaky like this. Today we're going to show you how that happens and why.
To truly understand the physics of sound, it is first important to understand what sound actually is. The Merriam-Webster Online Dictionary defines sound as mechanical radiant energy that is transmitted by longitudinal pressure waves in a material medium as air, and is the objective cause of hearing. Basically, this means that sound is just a form of energy, like heat or an electric current. This sound occurs in a medium, a fancy word for the surrounding particles in a location. We are surrounded by small particles, and we are able to survive within Earth's specific atmosphere.
Right now, we are surrounded by air. The air we breathe is composed mainly of nitrogen and oxygen, with atomic numbers of 7 and 8 respectively.
What happens in sound is that the potential energy of the particles becomes kinetic energy when one given particle is affected by another one within the medium.
When mechanical energy is released in the form of sound, let's say for example, by the vibrations of a wind instrument, a wave is formed, affecting the surrounding medium. The molecules in the medium, in this case the diatomic N2 and O2, strike each other and cause more movement. This creates a sound wave, a certain wave of vibrations.
Now we're going to take a look at what happens to sound when we change the medium in which it is created. The speed of sound in air at 20 degrees Celsius is about 343.6 meters per second, or a little under 770 miles per hour. This is about the speed limit Hubert drives at. This is why it takes time for sound to reach you, since velocity equals distance over time, and therefore time equals distance over velocity. Sound will travel to you in air at the speed of sound. When I play a note on the recorder in normal air, the sound is just as you would expect. However, when I use this helium, the pitch is raised considerably.
This is because the much smaller helium molecules, only second on the periodic table, strike each other more quickly. Since the medium has changed, so has the speed of sound. In helium at 20 degrees Celsius, the speed of sound is about 927 meters per second, or about 2,074 miles per hour.
In addition, because of Newton's second law of motion, we know that force equals mass times acceleration, and therefore that a given number of less massive hydrogen atoms should accelerate more than the same number of the more massive oxygen or nitrogen atoms.
This works with any kind of noisemaker in which sound is created by air pressure and vibrations. When the medium changes, the speed of sound changes. Take the voice, for example.
When you inhale through the balloon, your voice gets significantly higher than it was before.
Unless you're as manly as me. Now I will explain why our ears hear a higher pitch when this occurs. When we hear sound, we are actually hearing the vibration of our eardrums. Our eardrums are small membranes in our ears, each which must receive equal pressure on both sides to balance them. When a sound wave hits the eardrum, it causes it to vibrate. According to howstuffworks.com, the faster the vibration, the higher the resulting sound. This is why we hear sounds higher when they're created within a medium with a faster speed of sound. Because our eardrums, as a result, are vibrating faster. These vibrations trigger a series of neurological processes in which the brain translates the input from our eardrums into distinguishable sounds. And this brings us back to our guitar solo. Should I practice for the next show? Yeah, that sounds good to me. Thank you for watching. the sound is just as it would.
Wanna try it again?
With atomic numbers of 7 and 8 respectively.
Mr. Walker.
Mr. Walker. When you inhale the helium through the balloon,
Hi. No.
Your
same.
pitch gets significantly higher. How does that not work on you?
Welcome back to news at 10.
Good. Good. You're good.
Today's top broad. Oh, it's recording. Okay.
yeah, it's recording.
Is my hair up?
Yeah, it's fine.
This is why it takes time for sound to reach you. Did I already say this?
Yes,
I
you did.
Yes. Wait, no, that's not all.
Okay, but that part, Jen's gonna be like looking down randomly.
It's okay. It's okay.
No, you're gonna disappear.
I'm not gonna disappear.
What's happening? Now, why did that sound so good?
Because physics.